The Performance tab highlights any active service alerts. The Alerts view displays any active alerts along with alert history. Alert history is useful for tracking down intermittent alerts. Simply select a given day and the CSAP Events Viewer will launch. We can then see the timeline of any given alerts when they were active, which is red, and when they potentially have been resolved, which is green. On this first host, for example, this actually maps to a CSAP install. In the Active Alerts section, we can see that the test K8's CSAP reference 2 service has 530 files open, but it's been set with an alert threshold of 500. So the question is, how long has this been happening? What caused it to happen? And what files are open? If we can identify the open files, we can notify the engineering team of where to potentially look for resource leakage. To investigate this, we will go ahead and open up a host dashboard on Dev 11. We'll switch to the top view. We'll filter by the reference service. And then we can sort by open files. Here we see the service, its namespace, and then the namespace monitor, which aggregates all the open files open in the namespace. So to view the open files, we'll go ahead and use the CSAP command runner. We can load the command runner with the correct template by clicking the double arrows. By launching through the Top++ UI, note that the PIDs associated with the selected CSAP service have already been pre-populated. So now all we need to do is click on Run. A few seconds later, we can now see the full context of the process, so we know what the context is for which processes have launched it. If we scroll down a little bit, we can actually look at the open file descriptors that it's showing. So in this instance, you can see that the file that's been leaked under question happens to be named Java local leak container leak 71 along with the timestamp. Now in this instance, this is actually a CSAP test service, and we actually use the user interface to allocate these files to trigger the alert. In a real world use case, you need to look very carefully at each file and see if the patterns can be identified. Typically, the engineering team will need to look closely at their source code and at the leaked resource to determine the root cause. The other question we wanted to answer is, where was the alert level set? When was this triggered? To do that, we'll switch to the deployment view, select the CSAP test service, and from here we can actually click on the edit button and just confirm what the alert setting for the service is. So in this instance, we can in fact see that the open file limit is at 500. To get a sense of the timeline, we can select all the instances, then select Metrics, Open Files. Now we can see that the actual triggering event actually happened very recently. By default, the graphs are shown in stacked mode, but to make this more apparent, we can disable stacked. And now we can see just the node in question and the timeline in which it happened. It's worth noting that these analytic views are a few minutes behind real time. So if we wanted to actually see in real time, perhaps as part of a troubleshooting exercise, files being allocated, it would be useful to go onto the host for csap Dev 11. To do that, we'll go ahead, go to Dev 11, select the drop-down, and do OS graphs. And then here we can see the actual deployment of the service, along with when the files were allocated. And so in this instance, we can see that the detection happened shortly before 3 o'clock. One useful function of CSAP is then to take, knowing that we had an alert 1450, we can go back, look at the event browser, and see who is active in the system at the time that the alert started happening. Typically, that engineer would be able to answer the questions. So then the next question is, how would we resolve the leaked resource? A typical behavior would be to go to the Deployments tab and simply remove and restart the service. That would reinitialize, and in the case of a slow leak, that would work. In this instance, because this is actually using a test service, I can go ahead and launch it and then use the option to close any previously opened files. And you can see that it went ahead, closed the files, and then deleted the folder. Switching back to the top ++ view, we can now see the open files is now set back to a low number. If we switch to the process metrics, we can also observe that the process has released the open files. And similarly, we now see there's no longer any active alerts. And of course, this sequence of events has been captured in the events history. Open up the events log viewer, going to logs 10. We can now see that they were open, and now that alert has been resolved.